Welcome back to the channel, you guys, and I hope you guys are doing pretty good. So this is the day 7 of our 90 days SDET interview preparation series on YouTube. I hope you guys have gone through the old videos. If not, you're going to find a link in the description section. Now, in today's class, we are going to revisit a very important concept of Java. And I want to start this particular class by asking you a very interesting interview question. Can we access the private variables, private methods of a class outside in another class? Can we do that? Yes. Now, most of us will probably be saying that no, Jatin, we can't, because if the variable is private, if the method is private, we cannot access them outside the class. This is what we have been taught or we have been told so far. But there is a very interesting feature in Java which is called as reflection. And with the help of reflection, we can access the private members of the class outside the class. And this is how the interviews are asked now. You know, they are not really going to go in a Q&A kind of a mode. They'll technically drill you on the concepts, how well you know about a particular programming language. Most of the time when people reach out to me, they ask me, should I learn Selenium, WebDriver, Rest Assured or Playwright? What? The thing is, you're not supposed to focus on tools. You should always focus on technology. Because once you're comfortable in a programming language, once you're comfortable in a certain tech stack, learning these libraries are very simple. It's not going to take a lot of time. But understanding where you're going to use a certain design pattern, understanding the different features of a programming language, that is going to give you that extra unfair advantage. Now, before we get started with the topic of reflection, we go through the notes and all, we are going to understand how reflection works. And then probably we're going to go in this whole notes and all. Okay. Now, I just want you guys to observe over here. If you have your phone, if you have your any distraction around you, please make sure that you guys turn it off. For the next 1 hour or probably 40-50 minutes, it's just going to be you and me, and we'll be just focusing on understanding this concept of reflection. All right. So I hope you guys are ready. Let's get started. So over here, guys, I have already created the package, which is called as this com.day7. Day 6, we have not really created a package. We were focusing on understanding how to test the speech to text engine, right? Now, over here, I'm going to quickly create a class and we're going to keep it very simple. I'm going to create a class called as calculator. Okay. And in this calculator class, the first thing is I'm going to have a private variable, private integer x. Okay. Control Shift F. Let's fix the formatting. So this, you know that it is an instance variable created inside the class and is going to be non-static, is going to be called as instance variable. Instance variable is going to be created in the heap memory, right? Now, let's create another method and I'm going to call this particular method as add. And add method is going to have 2 parameters. Let's call this number 1 and number 2. And what add is going to do, it is just going to return number 1 plus number 2. Okay. So this temporary variable, which is going to store the result, I'm not going to create it. I'm just going to do the addition. And because we are adding 2 integers, this method is going to return us int. Yes or no? Perfect. So I've created a very basic class, calculator class. It has an instance variable and it has a method which adds 2 numbers. Now, what I'm going to do is I am going to create our runner class. What is a runner class? A runner class is basically a class in which you have your main method. Okay. So this is where I'm going to have my main method. And let's remove this particular comment. Let's zoom in a little bit so that you guys can see it properly. Let's bring this guy a little bit down. Now, what I want to do is I want to access the add method. So how we generally access the add method? Add method is basically an instance method. It's a non-static method now. So I need to create the object of calculator class. So I'm going to say calculator cal equal to new calculator. Tell me something, guys. What is an object? Is cal an object? No, cal is not an object. New calculator is the object. Cal, what we have created is what? It is the object or reference variable. Is the object a reference variable? If you guys are making notes, just write this particular stuff in your notebook. Calculator cal equal to new calculator, and just highlight cal and call this as an object reference, and this chap over here is my object. What happens when you create an object? Three things are going to happen. Class is going to be loaded into the memory. Instance variables are going to be created. Instance variables are created inside which memory? Heap memory. And one more thing happens. Constructor is called. Now, because we have not created the constructor in calculator class, if I go back to the calculator class, there's no constructor. Because we have not created the constructor, who is going to create the constructor? Java is going to create a dummy constructor. That dummy constructor is literally going to do nothing. Okay, and that constructor is going to be called. But generally, if you're going to have instance variable, okay, you're supposed to have a constructor, because the job of the constructor is to initialize the instance variable. I hope this part makes sense. Now, over here now, guys, I want to access the add method. So I would have written something like cal.add. You see, the moment I do cal.add, I'm able to access the method add, and I'm going to give 10, 20. Add method returns me integer, right? It returns me integer. So that result, I can store it inside integer, result. And probably I can print result over here. Okay, so if I'm going to click on the play button, bring this guy up, you will see 30 is getting printed for us. 10 plus 20 is 30. But inside the calculator class, we also have a private entity. So if I'm going to do cal dot, you will not find that private variable. X is not getting highlighted. And of course, X is not shown over here simply because it's a private variable. If I'm just going to change it to public, and I'm going to come back over here, X pops up. Okay. Now, let's change it to private. Now, what we want over here now, guys, is we want to access that private variable outside the class. So how we are going to do it? We are going to use something which is called as reflection. Okay. Now, when you're working with reflection now, the first thing that you need is a class reference. Okay. So what is the class reference? Okay. This over here you see is an object reference. Remember this thing. The cal which I have created over here is basically an object reference. When you're working with reflection, you're supposed to create something which is called as class reference. So how to create a class reference? Okay. So whenever you want to create a class reference, you're going to take the calculator class, the name of that class. Okay. And I'm just going to put a dot class. Okay. So this calculator class, which you see, right, it's basically your class reference over here. And you're supposed to store it inside a reference variable. Let's call that particular reference variable over here as class. Okay. Now, what will be the type of this class variable that we have created? It's going to be class. Okay. So over here, this class which you see, it's basically comes from java.lime. and it basically represents the classes and interface, okay, in a running Java application. So this chap over here, right, that we have created is basically the class reference. When you're working with reflections, right, you also have generics popping up. So you have this question mark. Question mark basically means that this class is going to have a type. Whatever you have kept in this greater than and less than sign, this is basically a type. So this class is going to have a type, and that type I have given as question mark. Question mark basically means it can be of any type. I'm having so many classes in this particular package, right? It can be a bank class, it can be a user class and all. So if you want to just make sure your code is a little bit flexible and all, you can really go with the question mark, okay? But if you really want to make sure that you want to create the class reference of a certain type, do nothing. You're creating a calculator class reference. Instead of putting question mark, put calculator. That's it. So you're going to say that this class reference is of calculator type. That's it. Okay. So now we have two kinds of references popping up. One is basically what you call as a object reference. And this chap over here, what we have is basically your class reference. Clear? Now, this is the starting point of your reflection, because you need to have class reference. So whenever you want to use reflection, you are supposed to use class reference. And class reference, guys, basically is storing the meta informations of that class. What do you mean by meta information? This class reference basically knows about the variables, whether it is instance variable or it is a static variable. It is aware of that. Along with that, it is aware of the methods and constructors. Okay? So these methods, variables can be public, private, protected. You can easily get all those information. Clear? Now, the next thing is, once we got this class reference, I'm going to use class dot get declared field. Okay? Get declared field. This is the method which I'm going to use. Field basically means your variables. Okay? And when you're talking about get declared fields is technically used when you want to access your private variables. So I'm going to say get declared fields, and it is asking me for a name. So this name which you see, you're supposed to give the variable name. What is the name of the variable? X. So I'm going to put X over here. What does get declared field returns me? It returns me a field. But hey, it is also giving me an exception, which is no such field exception. So please remember this exception name is because again in interview they ask what are the different exceptions you have seen in your project and all. And it is always better to talk about exceptions which people are not really talking about, because see, reflection you're definitely going to use in your framework. You should just be aware of how it is going to come. Okay. But over here in today's class, we're just focusing on the concept of reflection. Now, we are getting in this unhandled exception, no such field exception. Which is the best way to handle exception? Try catch or throw? You are always going to go with try catch. Okay? You're always going to go with try catch. But for convenience right now, I'm going to go with throws. Okay? I'm going to click over here. And this get declared field basically returns a field. Okay? So I'm going to say field X, something like that. Now, the thing is, this variable is private. I want to access it outside the class. How? I'm going to say x dot set accessible. X dot set accessible, and I'm going to set it to true. I'm going to set it to true. Done. Meaning this variable now is going to be accessible outside the class. So observe, if I want to get the value, what I'm going to do, x dot get. What do you want? I want to get the int value, right? That's an int variable. Okay. Now, over here, whenever you want to access the instance variable, you are supposed to pass the object reference. Which object reference? The calculator class. So I'm going to pass cal. This is also giving me an exception. So I'm going to throw this chap over here. So we're getting another exception, security exception, and illegal argument exception, illegal access exception, and all popping up. But this is what is the whole code. Now, if this thing works, and I hope it works, if I'm going to click on the play button, you will see 0 is getting printed. Let's go back. When you're going back over here, tell me, what is the value of x? It is an instance variable. Instance variable is created in the heap memory. If something is created in the heap memory, it is always going to be initialized with a default value. What is the default value of integer? 0. 0 is getting printed over here. But let's say, like Jatin, what if there's some different value? So let's assume that I put 10. Okay. So now x is technically initialized. Explicitly, I've initialized it with 10. So if I'm going to save it, I'm going to click on the play button. Ta-da! 10. What did I do? I was accessing the private variable outside the class. Is this part clear to everyone? Perfect. Just observe this particular code for a moment. Pause this particular video. If you want to practice it at your end, quickly do it. Now guys, you might be thinking, okay, this is what we need to do to access a variable, a private variable using reflection. But what if I want to access a method? Then what we are supposed to do? We already have an add method which takes 2 parameters, number 1 and number 2. All right, and it is going to return us integer data. So, how to access a method with the help of reflection? Same, you're going to use the class reference. So class dot get method. And over here, guys, you will see that you're supposed to give the method name in string format, and we are supposed to give something which is called as parameter type. So over here, method name is pretty simple. It is add. So if I go back to the calculator class, the name of this method is add. In string, I am giving this particular name. Next comes the parameters. The parameter type over here is integer, right? Number 1 is integer, number 2 is integer. So because your method is parameterized, okay, you have parameters that your method is going to accept. So you are supposed to pass the parameters. So over here now guys, we are going to give 2 integer parameters because add methods has 2 integer parameter. I'm going to say int.class. That's the first one. Second, int.class. Meaning we're going to get this method called add from the reflection, and that add method is going to take 2 integer parameters. Clear? Now I'm getting an exception over here. The exception is no such a method exception. So we're going to use throws to quickly put the no such exception. Now here's the thing guys. Why exactly you're getting this particular exception? What if your calculator class does not have a method that I'm trying to find? Let's say I'm going to say sub method. Subtract method is not there in your calculator class. So at that time, I'm going to get no such method exception. So anyways, we will be focusing on this add method. Get method returns me a method reference. Okay. So it returns me a method reference. So I'm going to create a method reference over here. So I'm going to call this method as add method. Control Shift O to do the import. So for your instance variable, you're going to use field. For your method, you're going to use method. Now, once I got this method reference, I can I can call this particular method. So I'm going to say add method dot invoke. And when we are invoking, you have to pass the object reference as well as the values for your parameters. So we already have created this calculator reference. Now, that is something we will be passing. Along with that, I am going to give the values to your argument. So 10 will be given to this chap, 20 will be given to this chap. Technically, we're going to give 10 to number 1 and 40 we're going to give to your number 2. Now, invoke is also giving me an exception, invocation target exception. So we are going to add throws declaration to put this chap over here. Okay. And invoke technically is going to return us something. The simple reason over here is because your add method is also returning us something. Na? So over here, add returns us what? Integer. Add returns us integer. So what I'm going to do is whatever your invoke is returning me, it's technically returning me an object. Whatever the stuff it is returning me, I am going to cast it with integer. Because we know that this method, your add method, is going to return us integer value. That's it. Done. Finish. We already have the result variable, so I'm going to make it result 2. And then I'm going to say this out. Result 2. Let's save this chap. Right click, run as Java application, and it works. 10 plus 40, answer is 50. Is this part making sense to everyone? I want you guys to quickly write this particular code at your end. And even if you're not writing, just observe this particular code. Okay? I hope you guys have done this stuff. Okay? So let's do a quick revision of what we have done so far over here, pets. The thing is now, deflection, to be honest, is not a very difficult topic. It's a very simple thing. It's just that when you start writing code like this, and if you have not worked with generics or you don't really understand the whole concept of classes and objects, then everything goes for a bouncer. The whole point over here, what reflection does is it gives you the flexibility to manipulate your fields as well as your methods without creating the object. Okay, and that too, you can actually manipulate these fields, the constructor, the methods dynamically during runtime. All right. Here, we already know that we are going to call this add method because we are using the object reference, right? So the moment I do cal.add, I'm supposed to select it from the auto suggestion which method I'm going to call. But over here, if you notice, I am giving the variable as well as the method name in a form of a string. Now, this particular value can come from anywhere. It can come from an Excel. All right. It can come from a properties file. Okay. So you guys can actually just fill your data, that which method do you want to call, okay, which variable you want to manipulate, and you put it inside a Excel file or a properties file. And when your program is going to execute, okay, it's going to read those properties file, it's going to read that Excel file, and based on that, it is going to call that method. So at runtime, dynamically, everything is going to be decided. Make sense? That's the power of reflection. Now, when you're working with reflection, guys, the thing is, something called class reference comes into picture. Now, when you're talking about this cal, this is what? Object reference. Now, when we are talking about class reference is going to store the meta information of that class. So over here, we are creating a class reference. So this class reference is going to store meta information of your calculator class. When we talk about meta information, what are the variables, what are the methods, what are the different types of constructors. All this information is stored, okay, and is your class reference variable is aware of. Now, once you have your class reference created, the next thing that comes into picture is this part, and this part is your reflection. So if I'm gonna bring my cursor to method or field, you will notice that it comes from a package java.lang reflect.field. So field, your method, they are all coming from reflection. Okay, the reflect package. I want to access a private variable outside the class. Generally, with your object reference, you can't do that. But when you're using reflection, you're able to do that. I'm going to use class.getDeclared field, and I'm going to give the name of that private variable. Perfect. And it is going to set that field. We're going to get that field. Then we are going to manipulate set accessible. I am making sure that I am calling this particular method set accessible equal to true, because we want to access this particular variable outside the class. And then I'm saying system.out.println, get me the integer value. But notice over here, we are supposed to pass the object reference. This chap, I'm passing it off over here. So during invocation, or you're trying to access the value, you have to pass the object reference, because these are instance variable and instance methods. Is this part making sense to everyone? When you are working with methods, you want to call a method with the help of reflection. You are supposed to give the method name, and you're supposed to give any parameters. So I'm giving the parameter type over here, that there will be two parameters, int. Then I'm going to invoke the method, and here also I am giving the reference, the object reference over here, and the two values for these parameters. 10 will be given to number 1, 40 will be given to number 2, and I'm going to get the result in object type. That object, we are casting it to integer, because add method is going to return us data in integer. We are casting it off, and then I'm printing result G. Is this part making sense to everyone? Okay. Now, what if you have a static method? Then what? Static methods don't belong to a object, right? It belongs to a class. So observe carefully. If I just create a public static, I don't know, demo method kind of stuff, and let's put over here public static void. I'm going to say sys out demo. Help me out over here how we are supposed to call this particular method. Let's practice that also. So imagine it's just a normal method for now. I'm going to say class dot get method. Which method I want to call? Which method I want to call? Demo method. And it does not have any parameters. So I'm just going to keep it like this. This is variable argument, right? So either you're going to have some arguments or you're not going to have an argument. If I'm going to bring my cursor over here, I hope it's just give me the suggestion. You will see that there are these 3 dots. So either you can pass this thing, or if there is 1 or 0 or more than 1 value, you can just pass those things over here. Okay, we don't have any parameters in demo. That's the reason I'm not going to pass anything. Get method is going to give me method reference. So I'm going to say method, demo method. Now I want to invoke this particular method. I'm going to say demo method dot invoke. And over here, guys, if I'm going to put null, okay, this method is still going to work. This method is still going to work because demo method is a static method. So invoke returns as object, but technically over here, it's not returning us anything. So whether you want to store it or you don't want to store it, it's completely fine. That's it. Let's right click, run as Java application, and you will notice that demo is getting printed on your console. But if you try to do this stuff over here, what is going to happen? Invoke null. Is add a static method? No, it is an instance method. So in order to access an instance method, you need to have an instance. Na? Object is an instance of a class. To access this particular object, we have this reference variable. You are supposed to pass this chat. If I'm going to put a null over here, I'm going to get null pointer exception. Let's click on the play button. Null pointer exception. Cannot invoke object.get class because object is null. So I have to put cal over here. I'm going to click on the play button. Is this part making sense to everyone? All right. So this is the basics of your reflection. Now what we will be doing, we're going to quickly go through the commonly asked interview questions from reflection topic. Okay. So over here, guys, we have these 5 questions, and technically I have taken these 5 questions from the code itself. Now, the first question is, what is reflection in Java and why do you need it? So I hope you understood by the example why do we need reflection, but let's try to just go with the theoretical explanation over here. Reflection is a Java API that allows you to inspect, manipulate classes, methods, fields, as well as constructor at runtime. So dynamic manipulation of all the class entities is possible, even if you don't know their names at compile time. Now, this is the most interesting part for us because, as I've said, in our framework, you can keep all the page classes name in a properties file or in an Excel sheet, and from there those class names will be taken and the respective page classes will be loaded, their respective objects will be loaded in the memory. Now the reason access private members. See, you cannot access private variables and methods normally. But with the help of reflection, you will be able to do it. So with the help of reflection, you will be able to bypass and access the private variables and methods. Now, some of you guys will be thinking where you will be using this kind of a scenario. This is not something that you should be doing in your project, but technically it is used for debugging. Then dynamic method calls. You cannot call the method name stored in a variable. So let's imagine you have a method name doLogin which is in string format. I cannot call it, okay, if the method name is in string format, because then that time you're technically using object reference. So everything is going to happen at compile time, because the moment you're using a object reference, the auto suggestion comes into picture. But if the data, if the method name, if the field name is stored in the string, you can use reflection and you can invoke them or you can access them. So you can use reflection to invoke a method which is stored in the string format. Dynamic object creation, this is also something very important. How do you create dynamic objects of a class? So you cannot create an object when the class name is also in the string format. Okay. But the thing is, with the help of reflection, it is possible. I have covered it in the future answers, but over here, this is something that you should be knowing over here. Now, in simple terms, remember that reflection is all about runtime manipulation, not compile time. Because compile time, you are able to do it anyhow now. So the thing is, whenever you want to do runtime manipulation, during the execution of the program, you want to change something, that time you would be using reflection. It is used heavily in our framework, whether it is in TestNG, Selenium WebDriver, Spring or Hibernate. And a lot of time in interview, they ask the question, have you used reflection? And people say no. But in your TestNG, it is there. Remember the page factory? Okay. So in page factory, it uses the concept of reflection. Okay, so Spring and Hibernate also uses your reflection. The package name, it's going to be good for you guys to remember that the package name is going to be java.lang.reflect. And the main classes from your reflection is the class, okay, for your class reference, method, field, and constructor. Okay, so this is basically the whole theory of reflection. Now let's go and look at the example also over here. This is the same example I have written a moment back. Now over here, guys, when you're saying cal c equal to new cal, this c that we have is what? This is a reference variable. Perfect. But what kind of a reference variable is this? This is object reference. Is this part clear? So with the object reference, you will be able to access the method. And this is happening at compile time while writing the code. Now you want to use reflection. That time you will be using class reference. So over here, get the class object representing the class. And over here, this chap is your generic, and this question mark basically means any class type. Now, when you're creating a class reference is basically going to contain meta information on that particular class. So what is the name of the class, the package name, methods, fields, constructor, all these information you will be able to access with this class variable. All right. Now, when you want to invoke the method, the first thing is class.get method and give the method name. Something like int dot class. It's not there, no? So looking at this particular line, tell me how many parameters the demo method is going to have. 0. Okay. And then I'm invoking this particular method, and observe I am passing this object reference over here. So over here, this demo method which is there, is this an instance method or a static method? This is a instance method. Okay, because you're passing the object reference over here. Now, if you look carefully at the bottom, I have another stuff, class.get method hello. This hello method also does not take any parameter, but I'm invoking and I'm passing null over here. So this basically means that you will be accessing this particular method in a static way. Okay. So this is a static method, and during the static method, you can pass the invoke parameter as null. If you are going to have any kind of parameters, so over here, you're supposed to pass the reference, the object reference. Either you can pass it over here or you can pass it during the invoke time. The second is the name of the method and the parameters. Whatever the values you are going to give during the invoke method, it will be given to these parameters. I hope this particular stuff makes sense to everyone. All right. Now, let's move on to the next question, which is, what are the 3 ways using which you can get class object reference or class reference? Okay. Now, observe carefully. Again, a second revision. Class C equal to new cal. So we know that this is a regular object. And when you're saying class, all right, this becomes a class object. Now, the thing is, now, it's really important to understand what is the whole purpose of this class object reference, because it is used to inspect the class constructor, private, public, static variables, and methods. It contains all the metadata, the meta information of your respective class. So that is the whole purpose of your class object reference. There are 3 ways using which you can obtain the class object reference. The first one is obviously with the dot class, which we just saw. And this is the most simplest one. Over here, You're just going to say cal.class and you're going to use the generic and you're going to get the class reference. And this is technically going to happen at compile time. For this, you need to know the name of the class at compile time. That's the reason I'm writing cal.class, right? So we know the name of the class, and if I know the name of the class during the compile time, you can use this class literal. This is the most common and technically most recommended approach to do this. You don't need to use any object, as well as no exceptions are going to come into picture. All right. The second way is using this get class. And the thing over here is now, get class is technically runtime. So you are going to use the object reference. Here you see cal c equal to new cal. I'm using the object reference and using the get class method to get the class object reference. Again, for this, you need to have the object created. Okay, the object needs to be created, and using that object reference, you will be using the get class method to get the class object reference. Want to get class from the existing object. No exceptions. Here also you're not gonna get any exceptions. The third one, this is something which is again interesting, because let's say I am going to store the class name in a properties file or in a Excel sheet. Okay. So I'm going to give the fully qualified name of that particular class in string format. And the thing is, this is something again where your reflection comes into picture. I can just say class, okay, dot for name, that is the name of the method. And here you're going to give the fully qualified name of that class, com.day7.carry. This is also going to give me the class object reference. Again, if you want to get the class object reference from the class name which is stored in the string format, whether it is stored in config, Excel or database, that time you're supposed to use this particular method. Loading class is going to happen dynamically, meaning when you're going to execute your project, your program, that time you will be getting the class object reference. It's not going to happen at compile time. Throws class not found exception must be the fully qualified name of the class. This is non-negotiable. Is this part making sense to everyone? This particular question, guys, is really important. It has been asked. The company was, I believe, Public Sapient. So please make sure that you study this thing properly. Now, as you guys know, the notes will be available in the YouTube membership. So if you guys want, you can just take the YouTube Tech with Jatin membership. You're going to find the notes over there. All right, let's move on to the next question, guys. How to access private fields using your reflection. I believe everyone is crystal clear with that. So we'll just quickly walk through all these steps. Over here, guys, the first is you're supposed to use the get declared field. And this particular chap is going to help us access the private field. Set accessible true. If you are not going to do this, set accessible true is not going to be set, then guys, you will not be able to bypass it. Okay, you will not be able to bypass the private access. Then field.get. Okay, over here, you're going to give the object reference to technically get the value of that particular field. But if you want to update, you can do that with the help of set. So obviously you have the getter and the setter methods available, and you can use the getter to get the value and setter to set the value. Look over here. Here, very simple example. Cal, private string calculator name is there. First thing, create the class object reference. Class.get declared field. This chap is going to help me access the private fields. And here I am going to give the name of that particular variable. The next thing, this is important. You are going to set the field, the set accessible as true. so that you can bypass the private access and you're gonna make some modification. If you want, you can do that. So over here, if you want to get the value, you're gonna say field.get C. So over here, the C is your object reference. So we are supposed to create an object of calculator class also, and this C I am supposed to pass it off over here. If you want to make some update, you can use the set method. Is this part clear to everyone? Similar to this, if you want to access the private methods, you are going to use get declared method. Get declared field is for private variables, and get declared method is for private methods. You're going to give the name of the method. If there are any parameters, you're supposed to pass the data type int.class, int.class. So you know that multiply method is going to have two parameters and their data type is integer. And I have to set accessible as true here also. Then I can invoke that particular method and I have to pass the object reference followed by the values for these two parameters. I'm going to get the result and I can just simply print it out. This is again important. It has been asked. Okay, please pause it. If you want, you guys can take a screenshot. Whatever works for you, just make sure that you go through this point properly. Alright, I hope you guys have gone through this one. Next one. This is important. I had actually created a YouTube short on this particular question. And this particular question is how to create objects without using new keyword. Again, that has been asked. Again, the answer to this particular question is reflection. So look carefully. First, I'm creating the your class object reference. Then over here, we are using the class object reference. This chap. Let me use pen over here. That would be better. And we are using a method called new instance. Okay. Just say the new instance. Technically, this whole stuff is technically going to create an object of calculator. So without using new keyword, it is going to create that object for us. All right. And the thing over here to remember, from Java 9 onwards, it has been deprecated. So you cannot use it in future or the latest version of your Java. If you want to create the object of the class without using the new keyword, then there is technically one extra step that has happened. You're supposed to first create the constructor. So over here, using the class object reference, I'm going to get declared constructor. I'm going to get the constructor first. All right. And that constructor is going to create a new instance. That's the only thing. Okay. One extra step came into picture. That's it. Suppose my class name was inside a string or inside a file, inside an Excel, whatever. So you will be using the class for name, okay, this particular chap, and you're going to create the class object reference. Once the class object reference is created, then you will be using the get declared constructor, and then to that particular constructor, you will be using the new instance method. Make sense to everyone? Perfect. Again, they have asked this particular question in interview. Please make sure that you remember this particular step properly. Now, the final stuff. Reflection looks cool, but what are the disadvantages of using reflection? Just remember these points. So the main thing over here now, reflection is going to make your entire execution 2 to 3 times slower. All right. So compared to your normal object reference and then calling the methods and all, which is technically a better approach to call and access the methods and the fields, reflection is a little bit slower over here because there is an extra step, right? Because we need to find the method, check the access, and then you're supposed to invoke. JVM cannot optimize the reflection like how it does for direct calls. Type checking happen at runtime and not compile time. Type checking happens at runtime and not compile time, and that's the reason it's slow. That's the reason it is slow. Second point, the disadvantage of reflection is that it breaks object-oriented concepts. It breaks your encapsulation rule. Variables should always be private. But when I'm using reflection, I can modify that. I can access private variables outside the class, which is actually a bad practice. So you can access and modify private members, which violates the entire object-oriented principle. So why this is bad? Because obviously you're bypassing the validation logic. You violate the private contract and makes the code unpredictable and unsafe. Next point, no compile time safety. See, the thing is, when you are using object reference, you technically get a little bit of compile time check. But in reflection, that is not there. Everything is going to happen at runtime. So even if there is an error, that particular error, you will not be able to catch in compilation time. You will only be seeing that particular error when your program executes. So error appears at runtime, not compile time, which technically makes it harder to catch bug. So bugs are discovered late, more difficulty in debugging. No IDE autocomplete help is going to work over there, and typos not caught until runtime. So even if you are making some mistake, in putting the class name, method name, or the variable name, those things you will not be able to catch it up during the compilation. You will only come to know about all these things when your program is going to execute, that is during your runtime. Okay. So that's all, guys. That's all we had for today. That was your reflection topic. I hope this particular lecture had given you a little bit of a quick revision on your reflection. In case of any doubts and queries, you can definitely comment your questions in the comment section, and I'll try my best to answer it off whenever I get time. Please take care, guys. I'm going to see you guys in the next one. Don't forget to mark your attendance. Till then, take care. Bye-bye.